Hello students, today our topic in mathematics is the right circular cone. As we are continuing surface area volume, this is another 3D solid figure. If we draw it on a plain paper or a board, it just looks like a triangular face and it has a circular base. For example, the top or most popularly your birthday joker cap is of conical shape. If we see that the vertical height is taken as the height of the right circular cone, the center towards its end is its radius, and the sloping line is called its slanting height. So, a right circular cone having the base circle has a radius which we denote by r, the vertical height as h, and the sloping height as its slant height. Now, if we take only the curved surface area or the curved faces of the cone, we will get its curved surface area. Curved surface area of cone or the right circular cone is pi r L, and the total surface area of cone is pi r into L plus r. If we add the circular area to its curved surface area, we get the total surface area of the cone. And there is the relationship between the slant height, vertical height and the radius, because it forms a right triangle. The vertical height with the center of the radius or the center of the circle makes a right angle. So, we usually call it a right circular cone. The right triangle thus obtained has a relation which is popularly known as Pythagoras theorem. If you want to find out any missing side of the cone, you have to use the hypotenuse square is equal to base square plus perpendicular square. If you want to find out slant height, it is root of r square plus h square. Let's do some type of questions regarding curved and total surface area of cone. And let's take one example. The diameter of a cone is 10.5 centimeter. Is 10.5 centimeter, and its slant height is 10 centimeter. Slant height of the cone is 10 centimeter. If we draw that cone on a plain paper, you will find that one of its faces is of triangular shape. In fact, from wherever angle you see the cone, it always has a triangular face, a curved triangular face. This is its vertical height, this is radius, and that is the slant height. Slant height is given as 10 centimeter and the diameter is 10.5 centimeter. We should note that to find the total surface area or curved surface area of a right circular cone, we do not need the dimensions of vertical height. What we need is its radius and slant height. Now, what will be the radius of that cone? It is the half of its diameter. That's 10.5 divided by 2, which is equal to 5.25 centimeters. Now, the curved surface area of the cone. By cone, we mean right circular cone. It is pi r L. Pi to be taken as 22 by 7, r is 5.25 and L is 10. So, when we calculate all this, we get 525 by 100 into 10, 749, 75, it's 515, 52. So 22 into 15, 330. How much is that? 22 into 15, let us find out. It's 330 centimeters square. Divided by 2, that is 115 centimeters square is its area. So the curved surface area of that cone is 115 centimeters square. Fine. Let's again find out what is its area. It is pi 22 by 7, radius is 5.25 and height, the slant height is 10 centimeters. So when you calculate, it is 0.7749. So 22 into 7.75 into 10 is 7.5. So 22 into 75 by 10. It is 165 centimeters square, in fact, the curved surface area of the cone. Now, you see without base, the surface area of the cone is the curved surface area of the cone, and it is 165 centimeters square. Let us take another example. We are given a right circular cone with slant height 21 meter and diameter 24 meters. The diameter of the cone is 24 meters and the slant height of the cone is 21 meters. Now, we need to find the total surface area of that right circular cone. The diameter is 24 meters. Diameter of cone is 24 meters. Therefore, its radius will be half of its diameter. That's 12 meters. Now, slant height of the cone is 21 meters. Therefore, we need to find the total surface area of the cone. Now, what is total surface area of the cone? It is pi r into L plus r. So, total surface area of that cone is, the relation is pi r L, pi is 22 by 7, r is 12 and L is 21. and we need to add L plus R. The total surface area of cone is pi r L plus R. Pi is 22 by 7, R is 12, L is 21 plus 12. So, it is 22 by 7 into 12 into 33, and which all is equal to 12 into 33, it is 396 into 22. It's 8712 by 7 centimeters square, because the unit is in meters, therefore its area is 8712 by 7 meters square. This is the total surface area of the cone. Now we are given that curved surface area. Another question is there. The curved surface area of cone is 308 centimeters square. So another question. Curved surface area of cone is 308 centimeters square, and its slant height L is 21 meters, 14 centimeters. Find the radius and total surface area. We need to find its radius and its total surface area. So, in this question, it's to find out what the radius of that cone is, and after that we can find its total surface area. To find the radius, total surface area, we need to find, that's not the L, so using a relation for curved surface area of cone, using relation, curved surface area of cone is pi r L. It is 308 is equal to pi taken as 22 by 7. R we do not know, and L is 14. Cancelling 14 with 7. 22 into 2 is 44 into R. And R is equal to 308 by 44, that is 7 centimeter. So the radius of that cone is 7 centimeter. Now we can use the formula for finding the total surface area of the cone. And we know the total surface area of the cone is pi r into L plus R. Now, total surface area of that cone is given by pi r into L plus R. L is the slant height. Now, pi taken as 22 by 7 and R we found out it was 7. L what is the slant height of that cone? It is 14 centimeters and radius again 7, that we found out. 22 into 21. How much is that? It is 462 centimeter square is the total surface area of that right circular cone. Now we move to another question. There is a conical tent we are given a conical tent. Suppose this is the conical tent. And in that conical tent, we are given its vertical height as 10 meters. And radius of its base is 24 meters. This the radius of its base is 24 meters. We need to find its slant height and the cost of canvas for making that tent. One thing we must note that whenever we are told to find the area of the canvas used for making the tent, we should not take its base into account. Every time when you need to find the amount of material used for making a conical tent or anything which is of a conical shape, the base, the area of the base is not to be taken into the account. So whenever you are told to find the amount of material used, always find curved surface area of the cone. So in that question too, we are given the vertical height 10 meters, the radius as 24 meters, and we need to find its slant height. And also we are given that the canvas used in making that tent costs rupees 70 per meter square. Now what is given in that question? Let's see. The radius of that conical tent is 24 meters. The vertical height can be simply written as height of that conical tent as h, and which is 10 meters, and what we are missing is the slant height. Slant height to be denoted as L, this is missing, and the cost of canvas in making that tent is rupees 70 per meter square. So we will first find out the curved surface area of the tent, that is the actual material used for making that tent, and after that we can find out the total cost for making that tent or for bringing the material for that tent. So we are given that if slant height is missing, by Pythagoras theorem we can write it as L, the slant height is the root of r square plus h square. So to find out slant height, we know L is equal to root of r square plus h square. L square is to be found out. It's r 24 square plus h 10 square. 24 into 24 is 576 and 10 into 10 is 100. It is square root of 676 and 676 is equal to 26. So the slant height of that cone is 26 meters. how we can find out the square root. Now, we need to find out the canvas in making of that tent, the canvas used actually. So, to find out the canvas used, we need to find the curved surface area of the cone. Curved surface area of cone is given by the relation pi r L. Pi is 22/7, r is 24, and L is 26. Now, to compute all this, how much this becomes? 24 into 26. It is 624 and multiplied by 22. It is 13,728 by 7 meters square. This is the curved surface area of the cone or this conical tent. Now, the next part of that question is that for making that tent, we need to find the amount for buying that material, that canvas, and that too at the rate of ₹70 per meter square. So, cost of canvas 1 meter square is given as ₹70. Therefore, cost of canvas, how many meters square for that tent? It is 13,728 by 7 meters square. That is equal to 13,728 by 7 into 70. It gives 1,37,280 rupees. So, for making that conical tent, the canvas costs 1,37,280 rupees. Hope that you understand that question. Now, we are given another question. I will read it for you. The length of tarpaulin, sort of canvas, which is 3 meter wide, will be required to make conical tent of height 8 meter and base 6 meters. Let's draw a rough figure for that conical tent. Now, what is given? The conical tent has height 8 meters. This is height. And the base of radius is 6 meters. Now, what is missing? It's the slant height. Or this way, the sloping line is the slant height. And for that, we need to bring a tarpaulin which is 3 meter wide. Assume that the extra length of material that will be required for stitching margins and wastage is cutting is approximately 20 centimeter. The question is, what length of tarpaulin 3 meter wide we need to make that sort of tent, and 20 centimeter in length is to be taken as extra margin for wastage or other cutting wastage or stitching wastage, whatever. If you want to make that type of conical tent, we first need to find its slant height, because for making conical tent, we need to find out its curved surface area. So, for curved surface area, we have to take the curved surface area equal to pi r L, and in that question we are given that the value of pi is 3.14 and extra wastage in length is to be kept as 20 centimeter. The width of the tarpaulin that is to be brought or that is available is 3 meters. So, how much length of that tarpaulin we need to make that sort of conical tent? Now, first we will write out what is given. The radius of that conical tent it is 6 meters. The vertical height h is 8 meters and the slant height is not given. So, to find out the slant height, we need to use the Pythagoras theorem there, and it is L, the slant height, which is equal to the square root of r square plus h square. R is 6 square and h is 8 square. Now, the square of 6 is 36 and the square of 8 is 64. It is square root of 100. That is 10 square, or we can say the slant height of that tent is 10 meters. Now, for making that tent, the canvas or the tarpaulin used is the curved surface area of the tent. Again, you must learn that for making the tent, the base of the tent or the base of the cone is not taken into account, it is only curved surface area. So, the curved surface area of that conical tent is pi r L. Pi is to be taken as 3.14, r is 6 and L we found out it is 10. Now 3.14 into 10 is 31.4, into 6 it is 188.4 meters square. This is the amount of tarpaulin which is used for making that tent. Now, again we go back to the question that the width of the tarpaulin that is available is 3 meters. Let we denote it by B, it is 3 meters, and the length to be purchased we do not know, let it keep at as L or X, because L means slant height for curved surface for this conical tent. Length of tarpaulin, let it be X meters. Let length of tarpaulin for making that tent be X meters. Therefore, area of tarpaulin used is 3x meters square. We will relate the area of the tarpaulin in terms of x with the actual curved surface area of the tent. So, when we relate it, we actually make an equation. So, according to given condition, three into x is the area of tarpaulin used in making that tent, and 188.4 meters square is the actual canvas in making that tent. So, dividing it by 3, you get 68.2 meters. So, the length of tarpaulin used for making that tent is 62.8 meters, but we are given that 20 centimeter is kept extra for the wastage, for cutting wastage extra. So, these 20 centimeters are taken into account and added with this length that actually is used in making that tent. So extra wastage in cutting is 20 centimeters. To convert it into meters, we divide it by 100. This is 0.2 meters. So therefore, the length of the tarpaulin that actually is needed to be purchased is 62.8 plus the wastage 0.2, and it brings 63 meters. So the 63 meters length of that tarpaulin with 3 meters is breadth will make us this type of conical tent with radius 6 meters, height 8 meters, and slant height is 10 meters. Hope that you have understood that question.